In this video, we are going to go over the Practice A2 solutions for Lesson 6.4 in Algebra 2. Let's get into it. And what I want you to do is to have your sheet out, and before you even begin the process, if you would like to tackle these problems on your own and then come to the video, that would be totally fine. But having said that, let's go ahead and go. Number one is prime, and here's the reason why. We have the trinomial x squared minus 4x plus 21. Now, because 21 ends in a positive, we now know that both signs have to be the same. So we look to the middle term, and we know that they both have to be negative. So I'm going to have x minus some number and x minus some number. So these two numbers have to multiply to 21 and at the same time add up to negative 4. Well, the only possible combinations for 21 using negatives is negative 21 and negative 1 and negative 3 and negative 7. But in both cases, neither of them add up to negative 4, and that's a guarantee then that number 1 is prime. Number 2, this factors into x minus 5 times x minus 11. The last term is positive, and again that means the signs are the same. Look to the middle, and now we know what they are. So they both have to be minus and minus. Now the reason why we're going to choose negative 5 and negative 11 is because 55 factors into negative 5 and negative 11, and negative 5 plus negative 11 is negative 16, and that's the middle term. So that gives us the answer for number 2. So when the leading coefficient is 1, these trinomial problems are very, very easy. But number 3, we get into a trinomial situation which the leading coefficient is not 1. And I've decided I'm going to use trial and error here and write out all the possible combinations. Now, if any of them work, it's only going to be one of them that works. And if I have truly written out all the possible combinations, then if none of them work, it's a guaranteed prime. But only if I really have written out all the combinations. And in this case, I have. And I would actually like you to pause the video just for maybe 30 seconds or so and just look at the different combinations and convince yourself in your own mind that I've written out all the possibilities here. So only one of them is the winner, and it turns out it's the first one. I really want you to understand trial and error, and that's why I took the time to write it all out. Yeah, my solution here is the first one, but that's not always going to be the case. So the middle term or the inner term, 3 times x is 3x, and the outer is 2x times negative 7, that's negative 14, and negative 14 plus 3 is my negative 11, and so that's why this factors like that. Okay, number 4, 3x squared minus 13x minus 10. Using trial and error again, I write out all possible combinations. So again, I would like you to pause the video and convince yourself in your own mind that I have written out all possible combinations. 10 can be factored as 1 times 10, but it can also be factored as 2 times 5. 3x squared can only be factored one way. That's 3x times x. So, okay, who's the winner this time? Well, it's 3x plus 2 times x minus 5. Doing the inner product, 2 times x is 2x. Doing the outer product, 3x times negative 5 is negative 15x. And we have a problem here. So 2 times x is 2x. Wow, I let that get past me, didn't I? Oh, no, it has to be a middle minus 13. I'll call it a typo. I don't know why I wrote negative 11x. I'm just tired. I'm sorry for that. So for some reason, I copied down this one to here, and that shouldn't be it. For some reason, and I don't even know why, this should be, which one was it? I apologize for that. There we go. There we go. So 3x plus 2 times x minus 5, that's what gives me 3x squared minus 13x minus 10. So my solution's correct. I just, for some reason, wrote down the original one for number 3 down here because I'm tired, I guess. Okay, moving on. Number 5. 28x squared minus 6x minus 4. We're going to use trial and error. There is something I could do to make this easier, but I'm not going to tell you right now. I will tell you, but not right now, because I want to see you. I want you to see. I really am tired. Wow. I really want you to see the benefits of doing the trial and error process, and I want you to see how useful factoring from the beginning can be. So we're going to write out 28x squared. That can break up three different ways. So 1x times 28x, 2x times 14x, and 4x times 7x. Negative 4 can break up, well, four different ways. Negative 1 times 4, 1 times negative 4, 2 times negative 2, or I could switch those around. And so I write out all possible combinations. Wow, there they are. So again, this is why trial and error is not popular, but again, I'm going to push it and promote it because I have experienced firsthand that if you stick with it, you actually get really, really, really stinking good at factoring, because it forces you to break up these numbers again and again and again and again. All right, so only one of these is the winner if any of them are the winner, right? Well, the winner turns out to be 4x minus 2 times 7x plus 2. Do the inner product, negative 2 times 7x, which is negative 14x. Do the outer product, which is 4x times 2, which is 8x. And then what is 8x plus negative 14x? Well, it's negative 6x. But notice something. 4 and 2 are both even numbers, and that means that you have a GCF of 2, so you can factor a 2 out to the front, and that leaves you with 2 times 2x minus 1 times 7x plus 2. And that brings us to what we could have done from the beginning. Notice at the very beginning, all the numbers are even. And because all the numbers are even, we can definitely pull a 2 out from the very beginning. And so if we had done that, if we had pulled a 2 out from the very beginning, we would have had 2 times 14x squared minus 3x minus 2. And then using trial and error on that would have been far simpler than using trial and error on this. Well, why didn't I do that? Well, again, I could have just told you what to do, but by doing it this longer way, you can appreciate how simple the problem gets by factoring from the beginning. And so one of the rules that I'd like you to learn to adopt is whenever you're given a trinomial, I want you to first look and see if there is a greatest common factor at the very beginning, because that's going to make your life way easier if there really is. And you can just factor it out. All right, number 6 just turns out to be the difference of two squares. X squared minus 9 is the same thing as x squared minus 3 squared. And so we use the template. This becomes x minus 3 times x plus 3. 5x cubed minus 20x. We have a greatest common factor here of 5x. And so this becomes 5x times x squared minus 4. But that's the difference of squares. So 4 is the same thing as 2 squared. So this factors as 5x times x minus 2 times x plus 2. Number 8 is x to the 4th plus 2x cubed minus x minus 2. So we factor by grouping. Look at the first two terms. What can you pull out of the first two terms? You can pull out x cubed. So we have x cubed times x plus 2. What can you pull out of the latter two terms? A negative 1. So you have negative 1 times x plus 2. And now you have a greatest common factor of x plus 2. So you pull that to the front, and you have x plus 2 times x cubed minus 1. But x cubed minus 1 is the difference of cubes, because 1 cubed is still equal to 1. So we use the template, or the know-it note, for difference of cubes. This becomes x plus 2 times x minus 1 times x squared plus 1x plus 1. And now that's completely factored. Number 9, 6x to the 4th minus 150x squared. The greatest common factor is 6x squared. That divides into both of these. And so we get 6x squared times x squared minus 25. But that's the difference of squares because 25 is 5 squared. And so that factors. And so we get 6x squared times x minus 5 times x plus 5. Oops, my 10 was exactly the same as number 9. So nothing new to do there. Yeah, look at number 12. We're getting to that. Number 11. What's the greatest common factor? 7x is the greatest common factor. So we pull out a 7x. And we get 7x times x to the 6th plus 8. But this is the sum of two cubes. X to the 6th is the same as x squared raised to the 3rd. And 8 is the same as 2 raised to the 3rd. So we use the template for the sum of two cubes, which is one of our know-it notes. And we get 7x times x squared plus 2 times x to the 4th, that's the square of x squared, minus 2x squared plus 4, that's the square of 2. Okay, number 12. I really like this problem. I do. This, for me, and I'm weird, and I get it, but there's something just infinitely satisfying about this. All right, so you look at the first two terms. What can I pull out of the first two terms? That's x to the 8th. So I pull out x to the 8th, and I get x to the 8th times x squared minus 16. What can I pull out of the last two terms? I'm going to pull out a negative 1. That gives me x squared minus 16. Now I have a greatest common factor of x squared minus 16, which I pull to the front. And now I have x squared minus 16 times x to the 8th minus 1. Now x squared minus 16 is the difference of squares, so no surprise there. That factors into x minus 4 times x plus 4. But x to the 8th minus 1 is also the difference of squares, and so that factors into x to the 4th minus 1 times x to the 4th plus 1. But just like those cheesy commercials you see on the Home Shopping Network, the person says, but wait, there's more, right? Turns out x to the 4th is also the difference of squares. And so I shuffle these other terms to the front, and I have x minus 4 times x plus 4 times x to the 4th plus 1. And then I factor x to the 4th minus 1 into x squared minus 1 times x squared plus 1. But wait, there's more, because x squared minus 1 is the difference of squares. And so I shuffle these other terms to the front, and I get x minus 4 times x plus 4 times x to the 4th plus 1 times x squared plus 1. And then I factor the x squared minus 1 into x minus 1 times x plus 1. And that's as far as it can go. And I remember when I was in algebra, I would look at x squared plus 1, and I would say, well, why can't I factor that? And the answer is because that's the sum of two squares. If I tried to factor that as x plus 1 times x plus 1, then go ahead and write that on your paper somewhere, x plus 1 times x plus 1. And if you FOIL it out, which I'd like you to do, you're not going to get x squared plus 1. You're going to get x squared plus 2x plus 1. And so the sum of squares does not factor the same way that the difference of squares factors. And so that's why this is our final answer. Number 13, tied into geometry. Recall from geometry that the volume of a right cylinder with a base area of B, actually a volume of a right prism, is what I should have had. Volume of a right prism with base area B and height h is B times h. And so if volume is base times height, then the base must be volume divided by height. So B of x equals V of x divided by h of x. And so I write out my polynomial division. And x plus 4 is a linear divisor, so I'm going to use synthetic division. Take the root or the 0 of x plus 4, which is negative 4, synthetically divided in. Drop the 1. Negative 4 times 1 is negative 4. 2 plus negative 4 is negative 2. Negative 4 times negative 2 is positive 8. Negative 10 plus positive 8 is negative 2. Negative 4 times negative 2 is positive 8. Negative 11 plus positive 8 is negative 3. Negative 4 times negative 3 is positive 12. Negative 12 plus 12 is 0. I now have the coefficients for b. So what happens is it goes down a power. It's no longer a fourth power. It's a third power. So b of x is, the base area polynomial is 1x cubed minus 2x squared minus 2x minus 3. All right, apologize I got so sleepy on this and I missed some things, but I hope I corrected them for you. God bless you wherever you are today.